Hey guys, welcome back to the next video. In this video, we are going to compare the Docker architecture with Kubernetes. We're going to see how Kubernetes is going to impact or how it's different from Docker. That's what we are going to see in this architecture. In terms of the Docker, it's as similar as the previous architecture. As you can see, the Docker directly connects with a container D service, which is hosted as part of Open Container Initiative. Now that the OCI is defined over here, the Docker container further continues to the host system's Linux kernel feature called namespace and control groups. Using those services, it will be able to create, control, and modify the containers which it has. Now, why there is a requirement of Kubernetes over here. As you know, Kubernetes is container orchestration. Now, the word orchestration means management. Now, management is required in terms of orchestrating the workload in terms of your containers. So that's the reason why Kubernetes is over here. Now, when you just talk about just Docker by itself, there is nothing, you can manage these images by yourself, as in like you need a person to in place to manage these images. If you want to scale up, you want to scale down, you need to have a person's interference in terms of scaling up your container images and scaling down your container images. Now, if you forget to scale up or scale down, you will have implications in your billing. Either you will be billed higher or lower based on the scaling up or scaling down. Now, as there is too much interference from human, so in terms of automating it towards orchestrating the management of this particular containers. So you kind of need an orchestrator. Now, Kubernetes works as an orchestrator in terms of controlling all these containers, which is created by Docker. Now, how we're going to do that is through something called a CRI, Container Runtime Interface. Now, Container Runtime Interface will be a bridge between your orchestrator manager, which is Kubernetes, and your OCI. Now, what is the role of CRI is that it's going to be a bridge between these two objects, and it's going to pass on the commands from the Kubernetes manager towards the OCI. In other words, the container runtime interface is primarily used in the context of a container orchestrator platform like Kubernetes. It defines a standard interface and an API for the container runtime to interact with container orchestrator. CRI enables Kubernetes or other container orchestrator, in this example, we are going to stick with Kubernetes, to manage containers, pods, and images. CRI implementation such as containerized CRI-O, in our situation, it's a container runtime interface for OpenShift. Is to ensure that it adheres to the interface to allow Kubernetes to control container runtime. On the other hand, OCI is a specification that defines standards for container images format and container runtime specifications. It provides a common format for packages and distributing it provides common format for packaging and distributing a containerized application and a standardized way to run containers. OCI is primarily concerned with the container format and runtime. So that's what these two's relationship is all about. So, using these two mechanisms, you will be able to use the Linux feature to control and manipulate the containers in terms of scaling up and scaling down. Can be right now done through Kubernetes by a set of instructions which it can monitor, and based on those instructions, it can scale up and scale down accordingly. Thanks again for watching this video. We will see in much more detail about the Linux kernel feature on the next video. Thanks again for watching this one. See you on the next one.